Okay, so today we're going to be talking about dilations and similarity. So first of all, let's practice a little bit with dilations, and then what we have in here is first the properties of dilation. This is huge and we haven't really talked about this. It says that dilation is not an isometric transformation, so the properties from the original figure and the figure that we're obtaining are going to be different, and that's what it means when we're doing reflections, rotations, or translations. So if I have this and I reflect this, rotate it, or I move it, I'm not changing the properties of this figure, it's still the same. Now with dilations, there's a few things that are interesting. The angle measures stay the same. So if you have a right angle and you make that right angle bigger, that right angle stays in there. That's not changing. We have parallelism. That thinks that if you have two lines that are parallel, then that means that the lines that you're getting are also going to be like parallel. So if you are dilating a square, and you have AB and A prime, B prime are going to be parallel. We also call that, and this is something that you already learned, dilations are called enlargement if the scale factor is greater than 1, and dilations are called reductions if it is greater than 1, greater than 0, but less than 1. Let's fix this typo here. Okay. Distance is not preserved, and that's huge on the huge difference between the rigid transformations and non-rigid transformations. So between reflections, translations, and rotations and dilation is that the distance is not preserved. After the dilation, the pre-image and the image don't have the same size. They have the same shape, but not the same size. And that's something that is really interesting and that you should keep in mind. Now I'm going to show you a GeoGebra demonstration, and it's really nice to see how the dilation, like you can see how the angles stay the same when you do a dilation, but the distances are changes. So let's go. Okay, here we have a dilation. If I move this, I can make the triangle bigger. Notice that one is between 1 and 0, it becomes smaller, and then what is a negative, it gets reflected. Okay, it's like the, not reflected, it's like the opposite, it gets flipped. Okay, now what we have in here, let's use this one. Let's notice this blue and this green angle, we're going to slide them. And notice that they are the same. And by the sum of the interior angles of a triangle, then if these two are the same, then this angle in here also must be the same because they add up to 180. If I make this bigger, same thing happens. The angles are still the same. Notice that this line in here, in this line in here are parallel. This line and this line are parallel. That's what we call parallelism. And the big thing is that distances are not preserved. So the distances changed. The length of, let me make this small, this length in here, it's completely different to this length in here. And that's it for dilations. Let's now move into the coordinate plane and how we dilate on a coordinate plane. So let's learn how to dilate figures in a coordinate plane. So there's 5 easy steps. The first one, if the figures given are not labeled, please label them. Write down the coordinates of the image given, which is the pre-image. So if I give you a figure, label, write down the coordinates. Done. We're going to multiply each coordinate, so x and y, by the scale factor. So if the scale factor is 5, you multiply x and y by 5. If it is 1/2, you multiply by half. Step number 4 is going to be to graph the prime coordinates on the graph, and then connect the points to create a new figure, and you're going to label it. Remember to use prime notation. And then the last step is to connect the image coordinates with its corresponding coordinates, so A with A prime, B with B prime, C with C prime, and connect them to make sure that your center of dilation is the origin, and it should be the origin. And if it is not happening, go back to your work, there's something wrong. For 8th grade math, we only do dilations using the center of dilation 0, 0. So let's go and let's move, and let's do then the first step. If you want to follow along, this is your workbook 14, lesson 2, page 14, problem 10. I am doing problem 10 and you will be doing problems on 11, 12, and 13. So first thing that I'm gonna do here, if I go back to my steps, is I need to label the figure. So that's the first thing that we're gonna do here. And it doesn't matter, you can call it PQR, XYZ, it doesn't matter. I'm gonna use A for this triangle, B, and C. So I label my figure A, B, and C. Let's then check what is the second step. Here it says that I need to write down the coordinates of the image given. So write down the coordinates of the pre-image. So let's go here and let's say, well, I have A, B, and C. I'm just gonna finish label like a few things. Like this book doesn't label X and Y, and that makes me really mad. So every single time you see a graph, make sure that you're labeling the graph correctly. So let's do step 2 here. And then A, B, and C. Let's write down these coordinates. For A, I'm sorry, it's gonna be 1, 2. For point B, it's gonna be 1, 2, 3, 4, 5 horizontally, so 5 on X. And then you go up 2 as well. And then point C, it's going to be 1. But then we're gonna go up 1, 2, 3, 4, 5. Done with the second step. Now, the magic of dilations happen on step 3, and this is actually when you are taking the figure and you are dilating the figure, even though you might not notice that that's what you're doing. That happens on step 3, when we multiply each coordinate X and Y by the scale factor. The scale factor is always given, so it's not a number that you need to figure out unless the dilation is given. So this number, if I go here, how much is my scale factor? 2. So I'm going to multiply each one of these coordinates by 2. So if I write this down, if I use my notation, I'm saying that xy, it's being dilated, and it's going to become 2x comma 2y. I'm going to multiply by 2 each x and y value that's within that parenthesis. So we are going to write A prime, B prime, and C prime. Let me erase this quickly so I use the right notation. I'm just gonna take all of this and I'm just gonna copy this in here so you can follow along the X and the Y. I'm gonna use a different color for my new coordinates. So A prime, and let me zoom in here. It says 2x, so 2 times the value of x. So for A, it's going to be 1. Okay, so 2 times 1, 2. Okay. 2 times 1 is going to be 2. And then it says that we need to take the value of y and multiply that by 2. So for the point A, that's going to be 2 times 2, 4. So you're going to multiply each individual x and y by the scale factor. It's not that you multiply only x or you multiply only y. You multiply both by the scale factor. So let's see in here, we're going to have 5 times 2. That's going to be 10. And then we have 2 times 2. That's going to be 4. And last, we have C. We take this coordinate 1. 1 times 2. That's going to be 2. And then we multiply y, which is 5. 5 times 2, 10. And these are my new coordinates, A prime, B prime, C prime. Done with step 3. Okay. So let's graph this A prime, B prime, C prime on the coordinate plane. First point that I'm going to graph is A prime 2 comma 4. So 2 comma 4. This is going to be A prime. Let's graph the point B prime, which is 10 comma 4. So I move 10 horizontally. 6, 7, 8, 9. This is going to be 10. And then I go up 4. 1, 2, 3, 4. And then I have C prime, which is going to be 2 comma 10. So 2, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Perfect. Now that we have A prime, B prime, C prime, step 3 also says that we need to connect these points. Okay. Step 4 says that we need to connect this point, so that's what we're going to be doing next. Let me make this a little bit thicker. Here you go. We going to fill this up, and that is my figure A prime, B prime, C prime. The scale factor is 2. That means that this figure should be 2 times bigger than the figure that we had originally. So I'm just going to check. This is not a step, but it's a way to check that your work is correct. If I see the length of AB, that is 1, 2, 3, 4 units. That means that A prime, B prime, if I did this correctly, should be 8 units. So we count 1, 2, 3, 4, 5, 6, 7, 8 units. That means that my work is correct. Okay, that's a quick way to check that you graph the points correctly. And now the last step that we have in here is connect the image coordinates with its corresponding coordinates. So A with A prime, B with B prime, C with B prime, and the center of dilation should be the origin. So all of them should connect at the origin. If that's not happening, again, you need to check your work because that means that there's something wrong. We are going to connect C with C prime. We're going to connect B with B prime. And we're going to connect A with A prime. See, this point in here that we are getting, that's going to be your center of dilation, and that way that step 5 is also a way to check that your work is correct. That is all that we have to do. Okay, that's all that we have to do. And before we continue, then now that we did the dilation, we can talk about the properties of dilation. So your practice, remember yellow background means you do. You need to label the figure, A, B, C, D. How do you label the figure? There's this text box in here that you can add, and then you just say, hey, this is gonna be A. Modify the size of your block and label the figure. This is not difficult, it's just a little bit, it's bothersome, not difficult. Then if you say, well, this is going to be A, and then you write the coordinates of A. That's all. When you write A prime, you just write A prime and use the prime notation. That's all you have to do over here. Make sure that you label the new figure, and then you write your A prime, B prime, C prime. You do your new box that should be 3 times bigger, and then connect the points. You have 3 problems. It's not difficult. It might take you time to work through the slides. Just be careful with this problem 12, which the scale factor is 0.25, which is a fourth. What do you think is going to happen? Is it going to become bigger, smaller? What does that tell you about the enlargement reduction? And then we have the number 13, which the scale factor is 1. So what do you think is going to happen? How do you think the figure will look like? That's all for this practice. If you have your workbook and you want to work on your workbook and then take a picture of your work, that's fine. If you find any other way that is easier than doing the lines and creating the new figure, go ahead and use it. That's all for video 2. Video 1.